The River Thames. A silver ribbon winding through the heart of London, the River Thames has always been more than just a body of water. It is a lifeline, a symbol, and a witness to the city's evolution. For centuries, it was a bustling waterway, central to commerce and trade. Ships from all over the world docked here, bringing goods, people, and stories from distant lands. But by the late 19th century, the river presented a problem. The very artery that had once facilitated growth was now a bottleneck. London was growing rapidly, especially the area east of London Bridge. The city's expansion was relentless, and the infrastructure struggled to keep pace. This growth brought more people, more carriages, and more goods that needed to be transported across the river. London Bridge, the only crossing point for miles, was overwhelmed. The congestion on and around London Bridge was becoming unbearable. The bridge, once a marvel of engineering, was now a choke point. The congestion on and around London Bridge was becoming unbearable. It could take hours to traverse its length, and the delays hampered businesses and frustrated residents. The city's lifeblood was being choked by its own success. It was clear that London needed a new bridge, one that could alleviate the strain on its infrastructure and accommodate the burgeoning city's demands. But this new bridge had to be special. It couldn't just be another crossing. It had to be something unique, something that would respect the river's activity while serving the needs of a modern metropolis. The challenge was immense. Any new bridge had to be built downstream from London Bridge to alleviate congestion, but close enough to the city to be practical. However, this area of the Thames was a hive of activity, bustling with ships and other vessels navigating to and from the Pool of London, the city's main port. A traditional fixed bridge would block the tallest ships from reaching these vital docks, crippling a crucial artery of London's economy. The river's traffic was the lifeblood of the city, and any obstruction could spell disaster. How could a bridge be built that wouldn't impede the river's traffic? In 1876, a special committee, the Special Bridge or Subway Committee, was formed to find a solution. They needed a bridge that could accommodate both the constant flow of river traffic and the city's growing transport needs. The solution they determined lay in a radical and innovative design, a bridge that could lift to let ships pass. A competition was announced, and engineers and architects from across the country eagerly submitted their proposals, each vying to shape the future of London's skyline. The excitement was palpable as the city awaited a design that would marry functionality with grandeur. This marked the beginning of an extraordinary undertaking, one that would see ambition, innovation, and engineering ingenuity combine to create an iconic landmark tower bridge. The bridge would not only solve a practical problem, but also become a symbol of London's resilience and forward-thinking spirit. The design that was eventually chosen was nothing short of revolutionary. It featured two massive towers connected by walkways, with a central span that could be raised to allow ships to pass. This ingenious solution ensured that the river's traffic would remain unimpeded, while also providing a much-needed crossing for the city's growing population. The construction of Tower Bridge was a monumental task, requiring the collaboration of hundreds of workers and the use of cutting-edge technology. It was a testament to human ingenuity and determination, a project that pushed the boundaries of what was possible at the time. As the bridge began to take shape, it quickly became clear that it would be more than just a functional structure. Tower Bridge was destined to become a symbol of London itself, a testament to the city's ability to adapt and thrive in the face of challenges. Today, Tower Bridge stands as a proud reminder of London's rich history and its enduring spirit of innovation. It is a bridge that not only connects two sides of a river, but also bridges the past with the future, a true icon of a city that never stops growing. The call for a new bridge across the Thames sparked a wave of creativity and ambition. The Thames, a vital artery of London, had long been a bustling hub of commerce and transportation. As the city grew, so did the need for a new crossing that could accommodate both the increasing road traffic and the ever-busy river traffic. Over 50 designs were submitted, each grappling with the challenge of spanning the river while accommodating its busy ship traffic. The designs varied widely, reflecting the diverse approaches and innovative thinking of the era's engineers and architects. Some designs were grand and ambitious, while others were more modest and practical. Some proposed tunnels, others suggested high-level bridges, and some even envisioned bridges that could be moved entirely out of the way. The idea of a tunnel was particularly intriguing, as it would allow uninterrupted passage for ships, but the technology and cost required for such an undertaking were significant barriers. The committee, tasked with choosing the winning design, had a difficult decision before them. They had to consider not only the technical feasibility and cost, but also the aesthetic impact on the cityscape and the practical needs of both pedestrians and vehicles. One design, however, stood out for its ingenuity and elegance. A bascule bridge submitted by Sir Horace Jones, the City of London architect, and John Wolfe Barry, a renowned civil engineer. Their proposal was not just a bridge, but a statement of Victorian engineering and architectural prowess. Their vision proposed a bridge with two towers connected by high-level walkways and a central span that could be split and raised to allow ships to pass. This innovative design would ensure that the bridge could serve both road traffic and river traffic without compromising on either. This design, while complex, promised to solve the bridge's unique set of challenges. The bascule mechanism, a marvel of engineering, would allow the central span to be raised quickly and efficiently, ensuring minimal disruption to both road and river traffic. The high walkways would offer pedestrians an uninterrupted route across the river, even when the bascules were raised, while the raising mechanism would keep the waterway clear for large vessels. This dual functionality was a key factor in the design's appeal, addressing the needs of both land and water transportation. The choice wasn't without controversy. Some criticized the bridge's aesthetic, deeming it too ornate for the industrial area it would inhabit. Critics argued that the elaborate design was out of place amidst the gritty industrial surroundings of the East End. Others questioned the feasibility of such a complex engineering undertaking. The ambitious design required cutting-edge technology and materials, and there were concerns about whether it could be built within the budget and time frame. However, the practicality and ingenuity of Jones and Barry's design ultimately won over the committee. Their proposal was seen as a perfect blend of form and function, promising to meet the city's needs while also becoming a landmark in its own right. With the design approved, attention turned to the daunting task of making this ambitious vision a reality. The construction phase would be a monumental effort requiring meticulous planning and coordination. The project was immense, requiring unprecedented engineering feats and a workforce of thousands. Workers toiled day and night, using the latest technology and techniques to bring the bridge to life. The construction of Tower Bridge would be a testament to Victorian engineering prowess and a symbol of London's ambition and progress. Upon its completion, the bridge not only facilitated transportation, but also became an iconic symbol of the city, admired by residents and visitors alike. Constructing a bridge across the River Thames was no easy feat. The project required not only immense technical skill, but also innovative thinking to overcome the numerous challenges posed by the river's natural environment. The riverbed, a mixture of soft clay and gravel, posed a significant challenge to building stable foundations. This unstable ground meant that traditional methods of construction would not suffice, and a more creative solution was necessary. To overcome this, engineers employed an innovative approach: caissons. These structures allowed them to work in a dry environment below the waterline, which was crucial for laying a stable foundation. These were enormous, hollow iron chambers, resembling upside-down boxes, which were sunk into the riverbed. The caissons were designed to be airtight, enabling workers to excavate the riverbed without the interference of water. The caissons were built on the riverbank and then floated into position. This process required precise engineering and coordination, as the caissons had to be accurately placed to ensure the stability of the bridge. Once in place, compressed air was pumped inside, forcing out the water and allowing workers to excavate the riverbed within the caisson's dry environment. This method not only kept the workspace dry, but also provided a safer environment for the workers. As the caissons sank deeper, more sections were added on top, like building blocks going down instead of up. This incremental approach ensured that the caissons could reach the necessary depth without compromising their structural integrity. It was a dangerous and demanding task, with workers facing the risk of decompression sickness, known as the bends, from working under high pressure. Despite these risks, the workers persevered, driven by the importance of the project and the promise of a better future. Once the caissons reached the desired depth, they were filled with concrete, forming the solid foundation upon which the bridge's iconic towers would stand. This concrete base was essential for supporting the immense weight of the towers and the bridge itself. Over 11,000 tons of steel were used in the construction of the two towers, which were clad in Cornish granite and Portland stone, both for their durability and to give the bridge a grand and imposing appearance. The choice of materials was not only practical but also aesthetic, ensuring that the bridge would be both strong and beautiful. The construction of Tower Bridge was a marvel of Victorian engineering, pushing the boundaries of what was possible at the time and showcasing the ingenuity of its engineers and the bravery of its workforce. This iconic structure stands as a testament to human innovation and determination, a symbol of the era's industrial prowess and architectural ambition.